Welcome to section 4.16. This is the 52nd session of the ISACA CISA exam prep series. In this session, we'll cover disaster recovery plans. We'll answer several questions. What is a disaster recovery plan and what is its goal? What do the recovery metrics actually mean? How do you choose a recovery strategy? What alternate sites can you use? What goes into the plan and its teams? And how do you test and invoke it? Why does this matter beyond the exam? Because when systems go down, the clock is your enemy. Picture a payroll provider whose data center floods on payday, or a hospital network knocked offline by an attack. A disaster recovery plan decides how fast you come back. It turns panic into a sequence of known steps. Get it right, and recovery is swift and orderly. Get it wrong, and downtime spirals out of control. So what is a disaster recovery plan? It is part of your internal control system for availability. Its job is to restore critical processing after an interruption. The aim is cost-effective controls that prevent and recover from disruption. An application's importance flows from the business process it supports. You define that importance through your impact analysis and recovery objectives. And this is a continuous process, reviewed and revisited over time. It produces two outcomes: longer-term strategies that reshape infrastructure over several years, and the plans themselves which direct the response to incidents. Above all, remember one priority: human safety comes first. In a fire, you evacuate before you ever think about restoring service. What do the recovery metrics actually mean? Start with the recovery point objective. It is the acceptable amount of data loss. If you can afford to lose 4 hours of data, your backup must be that fresh. Transactions in that gap get re-entered later as catch-up data. And some data never returns, which we call orphan data. Next is the recovery time objective. It is the acceptable downtime. It is the point by which operations must resume. Here is the key relationship. The closer either target gets to zero, the more expensive the strategy. A recovery point in minutes demands real-time replication. A recovery time in minutes demands a hot site and clustering. The lower the recovery time, the lower your disaster tolerance. A third metric is the mean time to repair. It is the average time to fix a failed system. A high value means longer outages and lost revenue. It depends on complexity, spare parts, and technician skill. A few more parameters round this out. The interruption window is how long you can wait before losses become unaffordable. The service delivery objective is the service level during the alternate mode, and the maximum tolerable outage is how long you can run in that alternate mode. How do you choose a recovery strategy? It pins down the most suitable route back for a system. It guides the detailed procedures you will later write. Your choice depends on 4 things: the criticality of the process and its applications, the cost, the time required to recover, and security. Present the alternatives to senior management. They select the strategy and accept the residual risk. The right choice balances recovery cost against the impact of an outage. And generally, every platform running a critical application needs a strategy. What alternate sites can you use? There is a spectrum, from bare to fully redundant. A cold site has space and power but no equipment. You must install hardware when you activate it. A mobile site is a packaged facility delivered on a vehicle. A warm site is partly configured with some equipment ready. You load current programs and data before resuming. A hot site has everything, with installed programs and recent data. Staff transfer in and resume quickly. A mirrored site is fully redundant, with real-time replication. It takes over with no interruption the users can feel. Then there are reciprocal agreements between similar companies. They sound appealing, but compatibility and enforcement make them unreliable. A few site rules matter. Place the alternate site beyond the reach of the same disaster. Always provide redundant network communication to it. And if a third party owns it, your contract must guarantee fast access. What should the contract for a third-party site cover? Quite a lot, so be thorough. Confirm the configurations meet your needs and stay updated. Check the definition of disaster is broad enough. Nail down access and priority if several customers declare at once. Confirm availability, speed, and limits on subscribers per site. Settle insurance, use period, and communications. Secure warranties, a right to audit, and testing rights. And confirm the site is reliable and secure enough for your policy. One related point on hardware. A cold or warm site needs equipment when activated. If your systems are standard, you can acquire them quickly. But if they are unique or hard to source, buy and store them in advance. Otherwise, you will miss your recovery time. What goes into the plan itself? The recovery plan follows the wider continuity process. It is a structured set of procedures written in plain language. It contains the rules for declaring a disaster and escalating. It states which scenarios are covered. It links to the overarching emergency and continuity plans. It names who is responsible for each function. It lists recovery teams, contacts, and step-by-step procedures. And it identifies the resources needed to recover and keep running. The scenarios are familiar. Loss of network, a key system, the processing site, data, an office, or a provider. Keep that section short, but always plan for the worst-case timing. How are recovery responsibilities organised? Around teams with clear assignments. Each team owns a function defined in the plan. The number and size of teams depend on the disruption. Some examples make this concrete. An emergency action team handles evacuation and protects human life. A damage assessment team estimates the harm and recovery time. An emergency management team coordinates everyone and makes key decisions. Other teams handle software, networks, transportation, and salvage. You do not memorize every team. You grasp that responsibilities are divided and assigned in advance. How do you test a disaster recovery plan? Because an untested plan is unlikely to work. Define clear test objectives first, then execute and evaluate. Have an independent party like an auditor observe. Expect recommendations and act on them afterward. The test types climb in intensity. A checklist review confirms the recovery checklists are current. A structured walkthrough has the team review each step on paper. A simulation role-plays a scenario without using the recovery site. A parallel test brings the recovery site live while production keeps running. And a full interruption test shifts everything to the recovery site. That last one is the most rigorous and the most disruptive. Start simple and grow more demanding to build confidence. How do you run and measure those tests? In the same 3 phases as before. A pre-test sets the stage. The test executes the real recovery tasks, and the post-test cleans up and evaluates honestly. Document everything as you go. Then measure the results quantitatively. Did you meet the recovery time? Was all required data recovered, meeting the recovery point? Could the backup site handle the throughput? And how accurate was the processing versus normal? Use those metrics not just to grade the plan, but to improve it. How do you actually invoke the plan? The continuity and recovery plans must align tightly. A designated person is notified the moment a trigger occurs. They work through an escalation path agreed in advance. You evaluate the incident to see which tested scenario it resembles. Then you mobilize the right teams. There may be several ways to respond. Choose the path most likely to meet your recovery objectives. Follow the documented procedures, but expect gaps. Testing may not have covered everything. So teams evaluate options at each step and document every decision. Those notes update the procedures once normal service returns. So let's bring it together. A disaster recovery plan restores critical processing with safety first. Recovery point, recovery time, and mean time to repair drive your choices. Pick a strategy by criticality, cost, time, and security. Choose an alternate site from cold all the way to mirrored. Write a plain language plan, organized into assigned teams. Test it from checklist up to full interruption and measure the results. Then invoke it through a clear escalation protocol. Master this, and a disaster becomes a process you can manage. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.